Hey, my friends, it is Mrs. Madsen. Today we're going to work with more decimals in the real world. We're going to be able to figure out if we need to divide or if we need to multiply to figure out an answer to a real world question. Probably the biggest key that I can give you, the biggest clue, is that if it says product, you will multiply. If you see the word quotient, you are going to divide. Those are the two biggest keywords for multiply and divide when you're out in the real world. So memorize those. It's going to make your life easier. A couple more clue words for multiply is the word each and total and every and especially the word times, right? And double and triple and quadruple. We know that double, if you double something, you're going to times it by 2. If you triple, you'll times it by 3. If you quadruple, you'll times it, not by 2, you'll times it by 4. But that double and triple are more common. You'll see that more commonly than you'll see quadruple. So when you multiply, it's going to be in a real life situation where you have a part that you're doing over and over and over and over and over again, and they're equal size groups. So you might have 4 that you're buying over and over and over again, like you're buying ice cream and it costs $4 and you're going to buy them for all your friends. How much is it going to cost you? Where you're going to do 4 plus 4 plus 4 plus 4. Anytime you're adding something over and over and over and over again, it's where you can multiply instead of adding it. So you're looking for parts that you are doing something over and over again. You're multiplyingly getting them bigger. So let me give you an example of what I'm talking about. Each candy bar is $1.25. If I buy 15 of them, how much will it cost me? So there's kind of 2 ways I could solve this. If each candy bar, if I draw a picture and each candy bar is $1.25, and I'm buying 15 of them, well, then I can go $1.25 plus $1.25 plus $1.25 plus $1.25, right? We could solve it that way. We would just have to do adding $1.25 15 times. You see how I use the word times? If I'm adding something 15 times, it's probably just easier if I just multiply. So that is an example of where I have a part that I am using over and over and over again. I am doing this part 15 times. So I'm taking $1.25 and I'm timesing it by 15, which I set it up like this, not even caring about the decimals. I am going to get, that's 10, 11, 12, 5, 6, add a 0 here. Give me some space right over here. 5, 2, 1. I will get $18.75. And if I wanted to quickly estimate it, well, each candy bar is about $1, and if I buy 15 of them, well, it's going to cost me about $15, which is close to my actual answer of $18.75. So that is an idea of when you know you're going to multiply. If you're doing something over and over and over again, instead of just adding and adding and adding and adding, just multiply it however many times you need to. Okay. So what about division? Well, like addition is the inverse of subtraction, multiplication is the inverse of division. So instead of finding the part, instead of finding that our total amount of all the candy bars was $18, in division problems, you were actually given that total and we're asked to divide it up over and over, like we're giving it away. Okay, so each is another keyword for division, as well as like equally or equal. If we're dividing something equally between people, we're going to be dividing. Per is a great keyword. Quotient, there's that quotient there. So let me give you an example of a time where you might have the whole and you're going to divide it into parts. So last week I made $52 babysitting for 4 hours. How much did I make each hour? So this $52 is my whole amount that I made for the whole entire week, right? So when I'm given the whole and I'm asked to figure out just a part of it, like it says for each hour, I'm given the total amount. I worked a total of 4 hours, and I'm wanting to know what that is for just each one of these hours. So you see I'm taking the whole $52 and I'm dividing it between each of my 4 hours that I worked. That is an example of division. So I also could have answered this question, what did I make on average? What was my average hourly wage? Okay, so average is another word I want you to put it in there because that's another very good keyword that if you're finding the average of something, you're taking the whole and you're averaging it out. You're dividing it between a certain part. So for this example, I'm going to take 52, that is my whole, and I'm going to divide it between the 4 hours. And that will give me how much I made for each 1 hour. So the first number always goes inside, and I'm left with $13. And that would make sense that if each hour I made $13, well, that would be 13 plus 13 plus 13 plus 13. If I did the inverse and did 13 times 4, I would get $52. So yeah, you can kind of do the inverse to check your answer to see if it is correct. So I made $13 each hour I worked last week. I worked a total of 4 hours, which gave me a whole total of $52. So when you're trying to decide between multiplication and division, it is very easily to be tricked because you'll often see the word each or per in both questions. So you're like, well, it says each, but that could be division or it could be multiplication. Well, my favorite way to think about it is the number that it's given you, is that the whole amount or is it just the pot? Is it just the part for like one candy bar? If you're just given the part, then you need to multiply to get to the whole. But like in this example, we were given the whole and we need to divide it down to get to the part. So that's one of the ways that works for me. Okay, if you still are like, here's one more strategy for you to use. Mrs. Jan, oh, hello, Maya. Maya, I need to call you back because I'm making a video, okay? Oh, hi, Lisbon. Okay, can I call you back in like 1 minute? I'm at school early in the morning. My kids are still at home. So they called me. All right, Mrs. Jan has 6 erasable pens and gives them equally to her students. So I have this word equally, which could mean I'm multiplying or dividing. That kind of works either way. So how many face masks does each, oh, this was supposed to be pens. We're so over face masks. I changed this to pens. How many pens does each student get? So if I'm like, well, it says equally and each person gets the same amount, well, I don't know if that's multiply or divide. Do one or the other. Let's say we're like, ugh, I think it's times. So we times and we get 1,200. Now, does that make sense with what the question was asking? The question is, how many pens does each student get? Does it make sense to say that each student gets 1,200 pens? Absolutely not. She only has 60 pens to begin with. So multiplication is definitely not the right operation to use in this problem. So then let's try the other operation. Let's try dividing. Let's take this 60 and let's divide it between her 20 students. That will give us 3 pens. Now, does it make more sense to say that if she has 60 pens and 20 students, that each student will get 3 pens? Yes, that makes complete sense. So if you're not sure whether you need to divide or multiply, try one of them and then see if it makes sense with what the question is. One is going to be like a bogus answer and you'll be like, there's no way that that works. And that kind of tells you, try the other one and see if that answer makes more sense. Those are my strategies for you. The best thing you can do is just practice. Go through the trail in your brain. It's going to be yucky at first, but the more you practice and the more you try things, the more your path is going to get cleared away and the easier it's going to get. All right, friends, happy mathing.